Hello everyone, I'll get started now. My name is Arvind and I'm a Senior Product Line Manager at VMware. So today I'll talk about how VMware is preparing for CXL and for many of you who don't know, VMware has been working on memory optimizations, and some of them that I'll cover today for quite some time now. Over the last 2-3 years, we've been working on several memory related projects. And we believe that we are ready for some of the upcoming technologies and vendor integrations because we have been working on those optimizations. So today I'll try to rush through some of this. Please hold your questions to the end. If you can't hold, then I'll try to answer if it's quick. But I'll try to rush through this because I tried to cram a lot into this 20 minutes. So this is standard disclaimer. So if you look, this is, I think a lot of you already know what this slide is about. But basically, your data is growing, and everyone realizes here probably that it has been growing faster in the last few years than it has the previous 20 years probably before that. So the analysts are predicting that data will grow to 175 zettabytes by 2025, and there is also a corresponding digital transformation in that a lot of enterprises are doing because of this data growth. They want to maximize the use of this data because data is being generated. A lot of them don't realize or don't know how to use this data to gain valuable business insights. So there is a push for among a lot of enterprises to see how they can maximize this use, and towards that they are using a lot of applications such as big data analytics, and you have AI/ML that is often talked about, and they're also doing a lot of real-time analytics. So if you can see on the left, there is a lot of trends that are going in the industry today. I mean, I talked about them now. There is a need for the processing to be real-time, and for that you need a lot of memory, and a lot of in-memory databases, and data needs to be processed in memory in real time, and for that you need scalability, and you need memory to be available. And the challenge is that today's systems, they don't really scale well, and we need memory, but there is no technology that can provide a memory cheaply and fast, and be able to scale seamlessly. So what CXL will bring is, it will definitely solve some of those issues. So there is a customer need. I think in terms of the infrastructure, there is also always a catch-up that is happening. I mean, we have all these applications that can scale and that need memory, but we don't have the corresponding technology. We also have a lot of in-memory computing. The other big part is customers are hesitant to deploy a lot of DRAM because it's expensive. And it also doesn't have the densities today that are required to run massive scale memory operations. So there is that need also, and then we have a need for monitoring. So a lot of customers want to understand how their memory accesses look like, what are the patterns, if there is any need for further expansion. So they don't have a clear view about a lot of the systems today don't provide that clear view about memory accesses and what is going on with their memory. So this is a typical pyramid that shows that today one of the core issues is that there are higher costs because if you look at the top of the pyramid, DRAM is expensive. And then there is also lower utilization. So we have something that's often talked about called stranded memory. So especially with VMware customers, we see that they over provision, they deploy it across the cluster, but a lot of the memory is unutilized. They do pre-allocate a lot of memory, and it's not really it's consumed, but it's not really utilized in the sense that it's not active 90% of the times. There is also a scale challenge. So we see that cores are increasing, but again I talked about utilization. So there isn't enough utilization of those cores. So which means that there is a need for DRAM to scale. DRAM doesn't provide the density, and thus you don't have enough memory, and thus you don't have good effective utilizations of the cores that are present on your system. So VMware's big memory vision, it starts with software tiering. So I mentioned at the beginning that we have been working on some memory related projects. So one of those projects is the software tiering project. So let me quickly talk about some of the VMware competencies. So having virtualization is, it makes it very convenient because what we see with virtualization is you could keep making improvements to your underlying hardware technologies. You could change your processor, you could add more memory, you could change I/O devices, you could do all sorts of underlying hardware changes, infrastructure changes. But from a customer point of view, they don't need to really change anything related to their workloads or to their applications. So they can run seamlessly. So they can bring applications, their workloads from maybe 3 years ago, and they can still run it in a modern infrastructure that's available next year, or with far better capabilities. So the other key value prop is distributed resource scheduler. So VMware from the beginning, one of its core tenets had been that it will provide resiliency for its customers, which means that customers do not have to worry about how their workloads are performing, because we provide this consistency guarantee. So what happens is if we find customers can configure their clusters in such a way that if they find that their applications are not getting the required performance guarantees or resource guarantees, these workloads can be moved automatically. So this is our DRS, and this ensures that there is consistency and resiliency, and it can help load balance and mitigate risks. The other value is with integration. So VMware already has a very strong partner ecosystem, which means that we have tens of thousands of devices listed on our VCG, which means that we can easily, we already have the framework, the certification, where we can onboard newer vendors, and they can come and certify their products with VMware. So we, on CXL, for example, we are already starting to work with a number of memory vendors. And our strong ecosystem provides a way for these vendors to be onboarded quickly. At the bottom, there are some technologies that I mentioned that we recently introduced. This is just a subset of the technologies. So this is to show that VMware can actually work very closely with the hardware and provide the support it needs from an infrastructure point of view. So we, for example, provided GPUs and sharing and dynamic direct path I/O. So which means that we are already in the journey where we have an ability to support devices that can be shared across a cluster. They need not be confined to a single host. So even though they are distributed, we could make them such that a workload running on a host that necessarily doesn't have the hardware resource can still utilize that hardware resource present in another host. And then SmartNICs, for example, we introduced SmartNICs recently with our latest release, and SmartNICs provide the offload capabilities, and they provide a lot of the benefits that customers like service providers need. So this is basically to show what kind of technologies VMware, just a sample of the type of technologies we support. I mentioned previously that across our customer base, we don't see a huge lot of active memory in use. So what that means is, when customers allocate hosts and they design their hosts, they design it in such a way that memory is always over provisioned. So there is a lot of DRAM available, and what that means is a lot of DRAM also gets wasted. Which means that if you have VMs and you size them appropriately, you do have these VMs consuming a lot of memory. But then when it comes to active workloads, there is just very few of that memory, very low percentage of that memory that is actually active at any point. So the reason I mentioned this is to show that this lends itself really well to use cases where you could have lower, basically slower memory, or memory that's not really as fast as DRAM, right? And you could still use such memory as another tier. So this is a quick slide on a sample cost benefit. So for a lot of the customers, TCO is important, and when it comes to CapEx investments, you can see how having DRAM being replaced by slower memory can drastically reduce their costs, so up to 20% in this case, and this is a real configuration. So what is the value with software tiering? So our traditional tiering approaches. So there is, we hear a lot of partners using traditional hardware approaches also, right? So with software tiering, first of all, this is transparent. So I mentioned virtualization, right? And what that means is that the VMs and containers do not even have to know what they are running on, right? So we hide everything beneath the virtualization layer, and so guests can continue running as is, and they can allocate from the same uniform address pool. We also have DRS and vMotion. So the advantage of this is with every release, we also feed more and more heuristics into our DRS algorithm. We try to improve it, and one of the things that we added in the last couple of releases is the ability to look into memory and look into the resource, memory as a resource consumption, and based on that be able to make decisions on migration. We also ensure fairness. So VMware being a hypervisor based operating system, we have a view of exactly how the workloads are running and how they are consuming memory, even how they are consuming the different tiers of memory. So what that means is that now we can do better decisions and make sure that rogue VM like scenarios, rogue workloads don't hog the memory and don't use the hot, basically the hotter tier or the faster tier all the time, and we can ensure such fairness. There is also zero configuration. So one of the goals of tiering for us is to make sure that this is completely configuration free, which means that the ESX, the operating system itself, manages the various tiers. It takes the responsibility of allocating the various tiers to the various VMs that are running. And then performance degradation, we always keep a view on performance, and we add more predictability and more algorithmic changes, such as prefetch or indications that can fasten, that can speed up some of the hot and cold page swapping kind of features to make sure that performance degradation is minimum. And then there is processor-specific monitoring. I mentioned monitoring is something we added, and then we are continuously adding more monitoring. Now we can monitor things like bandwidth usage on the various tiers, and we can also monitor, things like miss rates and, how each memory is being actually utilized, each tier is being utilized. So how does it work? So what we did is we modified the ESX kernel, right? So we made it such that it's tiering aware now. So on the right you see the modifications. So we did modify our memory management and some of our scheduling algorithm, and we made sure that we have a view on the various tiers, and then each of these components can make use of the different tiers and provide the necessary optimizations. So in future, we also want it to be pooling aware, which means that we will have an ability to share memory across hosts, which means that we will have a cluster-wide view. We already have some of this with the DRS, so we can extend the DRS to make sure that we are pooling aware, which means that if multiple hosts are using the same pool of memory, we can be aware of that and we can appropriately tier between those. So this is a sample that we also showed in one of the VMworld sessions. So this shows this is actually a real prototype, real data that we collected with slower memory. This shows that even with a sort of a 4:28, which is 1:7 kind of ratios between DRAM and slower memory, we can see a minimal performance degradation with a HammerDB-like workload. So this is basically what we intend to do. We provide a uniform pool, and then we try to do CXL or CXL with shared memory or remote memory, and we can even do CXL with software tiering, and in the future we'll also look into switches. So these are some of the key use cases that we are looking into that seem to be emerging in the industry. So again, lower TCO is one of the use cases that are really attractive to a lot of customers. So customers are trying to see if they can reduce their overall costs by combining slower memory with DRAM, and CXL can provide that capability. So they are also looking into memory expansion solutions. So a lot of the times, customers feel that they can just add more capacity and they can provide a flat expansion. There is also a need for higher bandwidth. So customers are looking to improve on their application bandwidth. So in those cases, memory expansion and additional CXL channels can provide that additional bandwidth and hence better performance. Memory sharing and pooling across multiple hosts. So this is also something that we will be looking into in the future. So we are seeing some vendors emerging with appliances who can provide both bandwidth and better utilization across the cluster. And finally, CXL switching. So I will end with some diagrams on expander use case. So on the right, you see how using an expander we could get better capacity and also additional channels, additional bandwidth for better performance and improving on the scale. So there is also a memory SSD kind of thing going on in the industry. So where we will be able to provide a faster tier and a slower tier. So I talked about software tiering. So we could use software tiering that is built into our kernel already, and it's ready to go. And we could combine a slower tier, and we could We could do this with minimal performance degradation. And finally, the memory appliance. So we could use a memory appliance and we could pool across hosts. So this is basically, a logical view and a physical view. We could have several tiers. This is specific to memory tiering. This shows that we could have multiple physical tiers on the right, but really all the customers see is a single DRAM tier. From which to allocate memory for VMs and containers. And finally, how everything fits together. So we have, I mentioned the DRS and monitoring. There is also the host monitor and VM monitor. We can monitor individual VMs. So which means that it's pretty powerful in the sense that we can look at individual tiers within a VM and we could adjust and balance the tiers. We could dynamically change the tiers within a VM itself. And we can actively do page placements for a certain VM. All right. I don't know if we have time for questions.